Hello, welcome to another video for numericals of work, energy, and so we have one more question, and in this question the following information is provided to us. The efficiency is 60%. Then we have the power output, which is equal to power input, which is equal to 2 horsepower. So we have the power input is equal to 2 horsepower, that is 2 into 746 watt. Now here is the situation. This is a pump. The pump takes in the power supply and then it lifts water. Okay, so this is the water coming in and this is the water being lifted. So the question is that the water has to be lifted to 5 meters and it has to be done in 40 seconds. So the question is, how much water can the pump lift? So for that, what we require is called as a power output. Now this pump is taking in 2 horsepower, and because the efficiency is 60%, the power output of the pump is 60% of what it consumes, that is the power input. So therefore the power output will be 60 upon 100 into 2 horsepower, that is 2 into 746 watt. So this is the power that the pump has to lift the water. And how much will be the work done to lift the water? That will be equal to mgh, and so the power will be upon time. So we have to equate this with this quantity and we'll see what value of m, as that they have asked what is the maximum amount of water. So we have m into g into h upon 40 will be equal to 60 upon 100 into 2 into 746. Now on solving, what we get over here is the following. So this is 6 into 2 into 746. Okay, this 4 will go up and this 5 is down and with a 10. So therefore this answer comes out to be, this answer will be 716.16 kilogram. This is the amount of water that can be lifted. Now let's move on to the next question. Here is our next question. So in this question we have a spring, and this particular spring is compressed when a toy is kept over here. So this particular toy is held, the mass of this toy is 0.15 kilogram, and when the force that was holding the toy is released, the spring will again try to come back its original position and this toy will be flung up, and it moves with a velocity of 10 meter per second as it is mentioned. So therefore what has happened is the toy will be in motion, and that means it has kinetic energy. And how much will this kinetic energy be equal to? It will be equal to the potential energy when the spring is compressed. So therefore potential energy, okay, of the spring is equal to the kinetic energy of the toy. Why? Because it is the law of conservation of energy. And so here we get half mv square, that is half into 0.15 into 10 into 10. So that will be 7.5 joules. So we have one more question over here, and in this question they are saying that there are certain alpha particles. So these alpha particles are passing through a particular point. So they are passing this point, and it says that there are certain number of alpha particle, like 5 into 10 to the power 12. These many alpha particle passed in 40 seconds, and these alpha particles are moving with a certain velocity, and that velocity is 2 into 10 to the power 7. So they are moving, they have kinetic energy, and they are passing through a particular point. So these alpha particle will have energy. We can also calculate power because we know how long they are taking to pass it, and thus we can also find those two things. Okay, so first they are asking for the energy. So energy is equal to n times the energy of one alpha particle, that is half mv squared. So n is the number of alpha particle, that is 5 into 10 to the power 12, and this is half into mass of each alpha particle is given 6.64 into 10 to the power minus 27 into v squared, that is 2 into 10 to the power 7 squared. So here we have, this is 5, 2 divided by this will be 3.32, and then I will write 10 to the power 12, 10 to the power minus 27, 2 squared will be 4, 10 to the power 7 squared will be 14. So again I will separate these right here. Now this is plus 12 and plus 14, that will be 26, and this is minus 27, so here we have a minus 1. Now this value, which is 5 into 3.32 into 4, is 666.4 in 10 to the power minus 1, so that will be 6.64 joules. This much is the energy. We need power, so that will be energy, that is work divided by time, that is 6.64 upon 40 seconds. So that will be 0.166 watt. Okay, let's go to one more question. So here is another question. This is similar to what we have done before. So this is a body of mass A, another body B, and the mass of body A is 20 kilograms and body B is 1 kilogram. Body A moves with velocity of 1 meter per second, and body B moves with 20 meter per second. Find the ratio of the kinetic energy. So kinetic energy will be equal to half into m into v squared. This will be also half into m into v squared. So therefore kinetic energy of A upon kinetic energy of B, this will be half into 20, and this will be half into 20 into 20. So I'll cancel this half, I'll cancel 120, and here you will have 1 upon 20. So your answer is 1:20. Remember, when they ask you ratio, leave your answer as a ratio. Okay, we'll solve more questions in the coming video. Thank you.